Okay, that very first question here, my least favorite instructions, simplify. But since we've got some numbers we're working with, I'm just going to follow the order of operations. I'm going to be following PEMDAS to get through this, to get to our best possible answer. So I'm going to do parentheses first. I don't have any. So next up comes exponents. 7 squared, I can evaluate that, and 7 squared is equal to 49. That's times 2. 9 squared is 81, and that's times 3. Next up, I dealt with my exponents. Next up is multiplication. So I'm going to want to multiply these two together and multiply these two together. Now, I would encourage you, if the numbers themselves are going to trip you up, go ahead and pull out a calculator. It's okay. But 49 times 2 is going to be 98. And 81 times 3, if I were doing this without a calculator, I'd think about this as 80 times 3 would give me 240. And 1 times 3 would give me 3. So that's going to be 243. In terms of doing that subtraction, if that feels a little bit gross to do in your head or to do by hand, again, I really do encourage you. It's okay. Pull out a calculator. 98 minus 243 is negative 145. Writing out the factors of 105, I'm going to start by looking at the fact that it ends in a 5, so I know that it has to be divisible by 5. So I know that this is going to be 5 times something. Now, if you wanted to practice long division and come off to the side, and here's 105, I'm dividing it by 5. 5 goes into 10 twice. 2 times 5 is 10. So when I do the subtraction, I'm going to get a 0 there and then bring that 5 down. 5 goes into 5 exactly 1 time. So I'm going to have a 21. Now, 21 factors further. 21 is 7 times 3. So in terms of my factors, that would be 3 times 5 times 7. This next one for solving, I know that my first objective is to get all of the x's on one side and all my numbers on the other. I'm going to choose to move my x's to the side that's going to make the coefficient in front of the x positive. So that means I'm going to choose to subtract 9x from both sides. I'm going to do this in 2 steps, but you could do it in 1. Negative 7. 11x minus 9x would be 2x. And then I'd have still that minus 9. Now my next step in terms of getting my x's on the right-hand side, I don't have my numbers on the left. I'm going to go ahead and add 9 to both sides. So I'm looking at 2x, negative 9 plus a 9 will give me 0. Negative 7 plus 9 is 2. And if you can't see, my dog is really desperate to get on my lap right now. And that's okay. So I'm looking at x equals 1. I want to pause just for a second. I went through those 3 pretty quickly. I am keeping an eye on the chat, but please chime in and let me know if you've got questions. Not seeing questions yet. I'm going to keep rolling. This next one, if I'm going to solve, I'm going to treat that inequality really as if it were an equal sign for now. And I'm still thinking about order of operations. So I'm thinking about PEMDAS. We do have parentheses here, which means I need to go ahead and try to simplify what's inside the parentheses. But I can't. These are not like terms. There's nothing more I can do to simplify those. So it's time to just distribute that 3 out for the parentheses. 3 times negative 3, that's going to be negative 9. 3 times 3x will give me 9x. That's all greater than or equal to 2. I want to keep the coefficient on x positive and it already is while it's sitting here on the left-hand side. So I'm just going to move the 9 and say 9x is greater than or equal to 11, which means that x is greater than or equal to 11 over 9. This question did not ask us to plot that on a number line, but just for good practice, because it is something that I expected you to do on quizzes and could show up on the final, let's make sure that if I were putting that on a number line, this says I'm looking for the numbers that are greater than 11 over 9. So those are going to live on the right-hand side. And because it's got that or equal to, I either want to use the square brackets for notation or a filled in circle. Either of those would be correct. Pausing just for a second, but not seeing more questions in the chat. I'm going to keep rolling. Got a couple of graphing questions up next. Here, I've given us some graph paper, asked us to plot some points. Sorry, make my phone quiet. In terms of plotting those points, I'm going to go ahead and start just by really clearly making some axes for us here, so that I've got a frame of reference for everything. 2, 1, remember the first number is the x value and the second number is the y value. Our x-axis is this horizontal axis and the y-axis is our vertical axis. So the point 2, 1 says move 2 steps to the right and 1 step up. 0, 3 says don't move left or right, so start at the origin and just move up 1, 2, 3 steps. -1, 2, that -1 says move 1 to the left of the origin and then up 2, 1, 2. And my last point, 4, -3, says take 4 steps to the right and then down 3. And those are all of our points. If I'm going to graph this equation of a line, we've got options, but for any line, I know that I'm going to need to label 2 points. So first, let me just draw my axes in and then get us 2 points to label. So one option is to look at the y-intercept and then use the slope to think about labeling a second point. Alternately, I can just find the x and y-intercepts, and that's going to be the route that I take. So to find the x-intercepts, we set y equal to 0. And if y is equal to 0, I've got 0 is equal to -2x minus 1. Or if I add the 2x to both sides, that would be 2x is equal to -1, or x is -1/2, which means the coordinate for that point is -1/2, 0. In terms of the y-intercepts happen when x is equal to 0. So that would look like y is equal to -2 times 0 minus 1. And the -2 times 0 is 0. 0 minus 1 is going to give me -1, which means the coordinate of that point would look like 0, -1. And I'll go ahead and graph those 2 points. So 0, -1, 0, -1, and -1/2, 0. That's right over here. And just going to kind of sketch this in, connecting the dots. Pausing for a second again, just to make sure. I still see nothing in the chat, but you're welcome to unmute yourself if someone has a question that seemed hard to type. Still not seeing questions, so I'm going to keep rolling through. For this next one, we've been given a linear equation and we've been asked to find x if y is equal to 3. We're simply going to replace the y's in the equation with the number 3 and then rearrange to get the x by itself. I've got 3x minus 5 times 3 is equal to 3 because I've replaced the y with a 3. That's 3x minus 15 is equal to 3. We'll go ahead and add 15 to both sides, which means I've got 3x is equal to 18 or x is equal to 6. Got another graphing one here. So I'm asking you to find the slope and the x-intercept for the given graph. We don't have to do anything with the equation. We can read both of these answers directly from the graph. So if I'm thinking about the x-intercept, that's this point right here. It's the place where the line intersects with the x-axis. Since that has an x value of -1, the intercept would look like -1, 0. In terms of the slope, slope is the change in y divided by the change in x. So just going back to that point, if I wanted to get from that point to this point, for example, we've taken 2 steps down and 1 step to the right. So that slope, if I think about it as a change in y over a change in x, that was down 2, but 1 to the right, or -2. We can come back to any question at any time if someone puts a question in the chat. Looking to find the equation of the line passing through these 2 points. I always need 2 things for the equation of a line. I've got to have a slope and a point. Well, in this case, I was given 2 of them, and we could choose either one to plug into our point slope formula. I've got y minus y1 is equal to m times x minus x1. And I'm going to start by just plugging one of the 2 points in, because I'm always looking to get partial credit first if I can. I'm going to choose this point. So I would have y minus 1 is equal to m times x minus 1. Next up, I do have to find the slope. Thinking about our slope, again, that's going to be our change in y over the change in x. It doesn't matter what order you put the points in, but you have to keep them in the same order for the top and the bottom. What I mean by that is, if I call this sort of point 1 and point 2, then on the top, I can take the difference in the y values as 0.2 minus 0.1, or -3 minus 1. But then I have to keep that in the same order from the bottom. And I'd have to use the 4 minus 1 on the bottom. -3 minus 1 is going to give me -4. And 4 minus 1 is +3. If we had chosen to subtract the points in the other order, that would also be fine. It just, we have to keep them, again, same order top as bottom. So if I had chosen to look at the change in y values as 1 minus -3 on the top, then the denominator would have had to look like 1 minus 4. And if we do that, 1 minus -3, it's the same as 1 plus 3, or 4. And the bottom, 1 minus 4, would give me -3. So these two are the same. We've talked about this a little bit in class. Doesn't matter whether that minus sign is on the top, the bottom, or sitting out in front of the whole fraction. All of those are equivalent forms. So my final answer here could look like y minus 1 is equal to -4/3 x minus 1. And that is how I would leave the answer. It's totally fine if you want to do this in y equals mx plus b form, but we don't have to. And this is the version that we use more often in calculus. Number 10 is a little bit messy, but simplify the expression means we're going to have to deal with all of those exponents. If I think about following PEMDAS, I do have parentheses. So the first thing that I would want to make sure is if there's anything inside of the parentheses that I could simplify. And it looks like all of these are already a simplified monomial inside the parentheses. Next up, I've got to take care of those exponents. There are a couple of different ways to correctly think about those exponents. I'm going to use exponent rules, which I think is the fastest way to think about those exponents, but it's also fine if you want to actually multiply things out. What I mean by that is if I have some stuff to the third power, that's equal to whatever is inside of those parentheses multiplied by itself 3 times. And you could do that for each of these terms. I'm going to choose to use the exponent rule that looks like if I have 5 to the third whole thing raised to the fourth, I know that powers raised to powers are going to get multiplied. So that would be 5 to the 3 times 4, or 5 to the 12th. So I'm going to use that. I'm going to use the exponent rule idea to get through this a little bit faster. For that first piece, that means I'm going to have 3. Yes, the numbers have to, the exponents apply to the numbers too. So I'm going to have 3 raised to the third, which is 27, x to the 3 times 3, or x to the 9th, y to the 2 times 3, or y to the 6th. 4 squared is 16. X to the 2 times 2 becomes x to the 4th. Y squared just gets written as y squared. And for my last piece here, 3 raised to the third is 27. X squared to the third is x to the 2 times 3, or x to the 6th. Now I'm going to bring things back together. Now I want to point out that if I'm not going to use a calculator, and you don't have to, I don't expect you to multiply out 27 times 27 times 16. What we might choose to do from a calculus perspective is to actually return those to each of their numbers raised to a power so that we can think about the numbers in their factored form as well. So that 27 was really 3 cubed, and that was also a 3 cubed, and that 16 was a 4 squared. So if I bring all of those numbers together, 3 cubed times 3 cubed is 3 to the 6th. Again, I'm using another one of those exponent rules. 2 numbers with the same base being multiplied together means that I add the exponents. So I'd have 3 to the 6th times 4 squared. Now let's go through and work with our x's and y's. If I take my x terms, so x to the 9th, x to the 4th, x to the 6th, they've all got the same base, and the exponent rule that I want to use is to add those exponents. 9 plus 4 is 13. 13 plus 6 is 19. So I'd have x to the 19th. When I look at my y values, I've got y to the 6th and a y squared. So when I add those exponents, I'd have y to the 8th. That's definitely the messiest one we've done so far. And I would leave my answer just like that. If you are going to use a calculator, which is fine, then in the calculator, you could also do 27 times 16 times 27 to end up with an answer of 11,664, x to the 19th, y to the 8th. And that would be fine also. Still seeing no questions in the chat. So I'm just going to keep going here. And it occurred to me, I should just I'm going to make sure really quick that no one has their digital hand raised. I don't see anyone with a digital hand raised. Okay, going to keep going. So number 11 when we multiply this out, again, that idea of the exponent, if I have something squared, it means it's being multiplied by itself. So this is equivalent to the square root of x plus 3 times the square root of x plus 3. I'm going to go ahead and do that with a box. You don't have to. You can distribute that out however you like, but I'm going with a box. The square root of x times the square root of x is x, and 3 times 3 is 9. But let's not forget about those two middle terms. So I'm going to have 3 times the square root of x. The 3 is not inside of the square root, the x is. And another 3 times square root of x. Now, combining like terms in this case, the x and the 9 are kind of sitting there by themselves. So I've got the x and the 9. But these two are like terms. I have 3 of the square root of x's plus another 3 of the square root of x's. In total, that means I have 6 square roots of x. Number 12, we've got a word problem here, but it's not too bad. The length of a rectangle is 6 more than twice the width. Write an expression for the perimeter of the rectangle. Since the perimeter is what I'm looking for, if I've got a rectangle and I'm just going to call this the width and this side the length, then the perimeter is equal to twice the width plus twice the length. But we've been given additional information in this problem, and that is that the length is, which means write an equal sign, 6 more than, so that's 6 plus twice the width. That's 2 times the width. Since we have this additional information about the length, we're going to use it in our expression for the perimeter. So my perimeter would look like twice w plus twice 6 plus 2w. And it'd be fine to leave it right there, or we can simplify that as much as possible, combine like terms. I've got parentheses, so thinking about PEMDAS, can I simplify anything in the parentheses? I cannot. I do not have exponents, so I'll move on to multiplication and make sure I distribute that 2 in. That's going to become 2 times 6 would be 12, and 2 times 2w will be a 4w. And if I put all of that together, that looks like 6w plus 12. Either this answer or this answer would be totally fine. Next up, we've got a division problem. Now, before we jump straight into long division, because we have a polynomial divided by something, I'm going to pause for a second because the bottom is just a monomial, which means I have the end, which means there's no addition or subtraction down there. And that gives me the option to actually split this up as 4 separate fractions instead of doing long division. And that's the choice I'm going to make. So when I split this up as 4 separate fractions, I'll have 6a cubed over 3a plus 18a squared over 3a plus 12a over 3a plus 6 over 3a. And now I'm just looking to simplify each of these as much as I can. 6 divided by 3 is going to give me a 2. There are 3 a's being multiplied together on the top and 1 a on the bottom. One of those a's is going to cancel out. Or we can think about this from the perspective of exponent rules and say the invisible exponent on the bottom is a 1. I'm dividing two things with the same base, so I can subtract the exponents. And 3 minus 1 would give me 2. Either way, this term would simplify to 2a squared. Next up, 18 divided by 3 is going to leave me with a 6. And a squared divided by a, again, I've got those two options. I can think about that as an invisible exponent of 1. 2 minus 1 is 1. That's a to the 1, or just a. Next up, 12 divided by 3 is going to give me 4. And a divided by a is equal to 1, so we're not going to write that one. And on this last piece, 6 divided by 3 is equal to 2. There's nothing to try to simplify the a with in the numerator. So 2 correct ways to write this would be to write that as 2 divided by a, or and then another equivalent form to that would be 2a to the negative 1. Pausing just for a second. Just as a time check, we're at 9:30. We've gotten through 13 of the problems. We might get through all of these. Let's keep going. Next up, I've got a factoring problem. And the first thing that I always want to do when I walk into a factoring problem is to see if there's a greatest common factor that we can pull out of all terms in the expression. So if I look at these three terms, if I look at these 3 terms, 5, 10, and 25 certainly all have 5 as a common factor. And then if I think about the x's and y's, I've got 4 x's here, 2 x's here, and 1 x here. So the highest number of x's that I can pull out is just x. If I look at my y's, I have 2 y's, 2 more y's, 3 y's over here. So the highest number of y's I can pull out is 2. If I pull a 5, an x, and a y squared out of the first term, what I'll be left behind with is x cubed. Now, when I say left behind, that means that if I were to multiply these 2 terms together, I would get back to where we started. Looking at that next piece, 5 times what would give me the negative 10, and that's going to be a negative 2. Now I'm going to look at my x's and y's. If I've pulled out 1x from an x squared, there's an x left, and I've pulled out all of the y squareds, so that's all we get. From the last piece, I need a negative 5, so that 5 times negative 5 would give me the negative 25 back. We've pulled out an x, and we've pulled out 2 of the y's from the y cubed, which leaves us with just a y. And that's my final factored form. Going to take a look at 15 now. We have options for how to solve this. And even though I didn't ask us to do this, I will just say, whatever else happens, I know that x cannot be equal to 4. That would be our restriction on the variable. Because if we happen to come up with an answer that x was equal to 4, it would mean that in the original expression, we were dividing by 0. So I'll just put that off to the side for now. When I look at this, I see that I've got a bunch of fractions, but I have an equal sign. So personally, I'm going to try to multiply the entire thing through by the denominators so that I get rid of the fractions. And I'm going to go ahead and do that in 2 steps. It's fine if you want to do it in 1. One denominator that I see here is x minus 4. So I'm going to go ahead and multiply both sides by x minus 4, just to get us started. On the left-hand side, when I multiply by x minus 4, and distribute that into the 2 pieces. When I distribute it into the first piece, I'd have 2 times x minus 4 over x minus 4. When I distribute it into the second piece, I'd have x minus 4 over 3. On the right-hand side, when I distribute it in, I have 4 times x minus 4 all over x minus 4. And you don't have to write out that step that I just did. I am doing it just to illustrate that what happens when we distribute that denominator in is that it disappears for 2 of those terms, because for 2 of those terms, that factor is going to cancel out. If I just take a moment to rewrite that, I now have 2 times x minus 4, 2 minus x minus 4 over 3 is equal to 4. I still have a fraction, so I'm going to multiply both sides by 3 and distribute that in. This time, I'm going to skip the step of writing it out, and I'm just going to notice that it should cancel. 3 times 2 is 6. And when I distribute the 3 over here, it's going to cancel with that 3 in the denominator. And I'll be left with minus x minus 4. And over here, I've got a 12. Last thing I need to do is distribute that minus sign out. Actually, I guess it's not the last thing I need to do. It is one more thing I need to do. Distribute that minus sign. I'm going to move my x to the right-hand side because I like to give it a positive coefficient. Six plus 4 would give me a 10. So right now I'm at 10 is equal to 12 plus x. And if I subtract 12 from both sides, I think I'm going to get that x is equal to -2. Taking a look at number 16 here, it takes me 15 minutes to walk 1 mile. How many miles can I walk in 1 hour? There are a lot of different ways to do this, and you might just think in your head, hey, 15 minutes is 1/4 of an hour. That means I should be able to walk 4 miles. Totally fine if you want to just think about doing that in your head. I'm going to write it out as a ratio. We're trying to figure out how many miles we can walk in 1 hour. That means we're looking for our final answer to be in miles. And we're going to do that in 1 hour. So if I think about that 1 hour, this ratio that we have of 15 minutes to 1 mile is in minutes instead of hours. So if I want those units to cancel out, I know that there are 60 minutes to 1 hour, which would make my units of hours cancel out. And then I know that I want my final answer to be in miles. So that means I'm hoping to get our miles on the top. And I've got 1 mile per 15 minutes. And now I'm hoping all our units work out, and they should. My hours would cancel and my minutes would cancel. And 60 divided by 15 is going to give me 4. So my final answer is that I can walk 4 miles. Again, this one, if you can do it and correctly get the answer in your head, totally fine to just skip to the final answer of 4 miles. Looking at 17, I've got 2 parts to this question. And for a bunch of you, I just graded the chapter 7 quiz today. And I will say a lot of people lost points on a similar problem to this on quiz 7 because you didn't do both things. So the first is to solve the system using any method, and then to graph the lines to verify our solution. Technically, that means you could have just graphed the lines and shown the solution on your graph. Doing that means you're going to want to be super, super accurate with your graph in order to find that solution. I think it's easier to find the solution using algebra first and then go to the graph. So I've got x minus y is equal to 3, and x plus 2y is equal to 0. Now, I'm going to choose to use the elimination method, which means I either want to get my x's to cancel out or my y's to cancel out. Either one is fine. I don't know why, but I just saw this as multiplying the top by 2 would make my y's cancel out when I added. So that's kind of the route that I wanted to take. I'm going to distribute that 2 out and just kind of pop it down here. So I'd have 2x minus 2y is equal to 6. Now the whole thing with elimination is that I want the same coefficient but opposite signs on either my x's or y's so that I can add the 2 equations together. X plus 2x would give me 3x. 2y plus negative 2y gives me 0y, or just 0. And 0 plus 6 would give me 6. And if 3x is equal to 6, that means x must be equal to 2. We can pop that 2 into either of the other equations in order to get y by itself. So if I put that into the top equation, that would look like 2 minus y is equal to 3. And I think that means that y is going to have to be -1. Now let's hope that that matches on our graph. That tells me that when I graph the two lines, they should intersect at the point 2, -1. Again, putting my x value first and my y value second. That first line, x minus y is equal to 3. If I think about finding the x and y intercepts here, if x is equal to 0, y would be equal to -3. And if y was equal to 0, x would be equal to +3. So that's my first line. And for the second line, if I find those intercepts, if x is equal to 0, y would be equal to 0, which means that's only 1 point. So it's not enough for me to graph the line, and I have to find another point. Any other point on the line will do. So I can just pick another value of x to plug in. For example, if I plugged in 1 for x, no, I don't want to plug in 1. I'm going to plug in 2 for x. If I plug in 2 for x, then 2 plus 2y would have to equal 0. And what do you know? Y is going to have to be -1. Now, why did I choose to plug in 2 instead of 1? Because I kind of needed it to work to show the second part anyway. So I know that 2, -1 is on that line. And now I have verified that that's a solution. Just a couple more here to go. We've got 10 or 9 minutes left. I think we're going to do it. But I'm going to solve this by completing the square. Yes, there are other methods that you could use to solve this, but I've said to use completing the square, so that's what we have to do to get our points. So if I'm going to solve by completing the square, I'm going to write this as x squared minus 4x. I'm going to give myself a little bit of space here. Scoot my -3 over. Next up, I'm going to take the coefficient on x, divide it by 2. Take the answer that I get, which is -2, square it, and pop it back in. -2 squared is 4. And so that I don't change the problem, I'm also going to add 4 to the other side of the equation. The reason that we're completing the square is so that we can rewrite this piece of it as a perfect square. So that's going to be x minus 2 whole thing squared. -3 is equal to 4. Next up, I want to isolate the part that is my polynomial piece squared. So I'm going to add 3 to both sides, which leaves me 4 plus 3 is 7. Now I can take the square root of both sides. So I'd have x minus 2 is equal to the positive square root of 7, or x minus 2 is equal to the negative square root of 7. I said square root, I wrote a regular 7. So final answer here, x is equal to 2 plus the square root of 7, or x is equal to +2 minus the square root of 7. Which should be the same answers that you would get if you used quadratic equation and then simplified your final answer. But it said I had to complete the square, so we completed the square. For numbers 19 and 20 on this practice test, it says we can factor, complete the square, or use quadratic formula, whichever thing we want to do. I'm looking at that first one and thinking, I definitely don't want to complete the square because that 5 in front of the x squared is going to make this gross. So I'm probably leaning towards quadratic formula. And part of that is that if I were going to try to factor this and to do our X box here, I would have 5 times negative 24 and then a positive 2. 5 times 24 maybe feels kind of gross to be trying to factor back out. I don't know. Or if I use quadratic formula, I'm going to have big numbers inside of the square root. Neither one's super ideal, but I'm going to go ahead and try for quadratic formula just for fun. I've got A is equal to 5, B is equal to 2, and C is equal to negative 24. So I would have X is equal to negative 2 plus or minus the square root. 2 squared is 4, minus 4 times A times C, all over 2 times A. Well, it looks like we didn't get around it. I still have to multiply big numbers because if you're going to use quadratic formula, I want everything inside of the square root simplified first. Or not first, but that's how you'll know when you're done. What's inside the square root should be a single number. If the numbers are stressing you out, please, please, please just grab your calculator, multiply the things together. 4 times 5 times 24 is 480. So this would, a minus would make that a plus. So I would have 484 inside of the square root. That whole thing, 2 times 5 is 10. And we could quit there and call that our final answer. If you wanted to multiply those numbers out by hand, I personally would probably do 4 times 5 first, because that would give me 20. And if I have 20 times 24, then really I'm going to think about that as 2 times 24. I can do that in my head and then append the 0 because it wasn't a 2 times 24, it was a 20 times 24. Looking at this last question, since we're on a roll with quadratic formula, maybe I would just keep going with that. I'm looking at A equals 1, B equals 7, C equals negative 10. And if I put that into quadratic formula, that means I would have negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times A times C, all over 2 times A. Inside of that square root, 4 times negative 10 would be negative 40. But minus a negative 40 is going to mean I'm actually adding those together. And 49 plus 40 sounds like 89 all over 2. We got the part in the square root down to a single number, which means we get to quit. We made it through all 20 problems, partly because no one asked me any questions in the chat. We've got 2 minutes left. I'm going to stop sharing my screen for a second. Does anyone have any last questions that they wanted to ask me today? And I do have office hours. I will have time that I'm down in the drop-in tutoring room next week. Oh, it looks like my thing that I did in the grade book where I was filling in zeros, it may have messed up quiz 9 because I haven't graded that yet. So I will go back in and grade. I haven't graded quiz 9, so it's possible that Canvas automatically gave zeros even if you had submitted those. I'll look into that this afternoon, but I haven't graded quiz 9 yet, so you can disregard whatever score it looks like you have on quiz 9. I'm going to stop recording.